So this video will try to explain different concepts, producer theory and market structure, together with other questions that might probably come in the exam. So my first question here, without wasting time, we'll just go direct into the questions. Okay, so the first question, or the first questions that I have here, are under production theory. Okay, so the first question has is this that we're given. First question says, from the table below, so they mean this table. Let me just put the pen there. So from this table that we have, A, find the AP and the MP of labor, and plot the TP, which is total product, and the AP, average product, and marginal product, which is MP of labor, curves on the same graph. Okay, so how do you do this? Probably you are going to maintain the factors of production that we have as labor, and the output that are going to be coming out from these factors of production that we have, if they add them on the fixed inputs, which is what? Capital. Okay, so under production theory, we have these concepts that follow. We know that production theory is just a process or a theory that tries to explain how firms combine inputs for them to, okay, sorry about that, inputs for them to produce what? Outputs. Okay, so with the question that we have, how do we find AP? The first question, which says find AP from the table that we have, how do we find AP? Average product is found by, so average product is simply the total product produced by labor. Okay, so as we have this total product, right? We have total product here, total product, total product. So what we're going to do here is we get this total product, which is 0, you divide it with this labor, per labor. So what we're going to do, if this we have 0 here, we divide it with 0. We have 2 here, we divide it with 1. We have 5 there, just like that until you reach the far end. So we're going to do that from this first part until the last part. So that's how you find your AP. Okay, your MP is going to be found by so total marginal product is simply, so marginal product of labor is simply the change in the total product over the change in the labor that you've been given, or the labor that you are using in production. Okay, so like here you're going to consider the change between this point and the first point. Okay, so you're going to be subtracting there. So you say 2 minus 0, and then 1 minus 0, then you divide. So the down part here is going to be divided by the upper part there, because we're saying labor is the one that is down in total product. So probably just follow this formula. Okay, and you do likewise as we did on the first part for AP. So that is how we find the first part. You go on the second part while you're asked to plot on the same graph. You're asked to plot on the same graph. So after you've found everything that we were asked, you have asked to find average product and marginal product. Total product we already have, and average product, I mean labor, we already have. How do you plot this on the same graph? So plotting this on the same graph will mean that you're going to draw something like that. I hope you can see from here. I don't have a whiteboard where I can write this, but I hope you're able to see from there. You can just, yes, okay. Okay, let me just try to maybe find somewhere empty space where we can try to put there. Okay, so we can draw something like that. Okay, so we're going to have total product that is increasing like that, then it will go up like that. It will reach its maximum there. There's a point that we call the point of inflation here. This point is a point where marginal product of labor reaches its maximum. So you can just draw something like that. You go in like that. Once it reaches there, it goes up and it goes down. Okay, so that's the maximum for marginal product. So this is marginal product of labor, and that is total product. Probably this is going to be equated this side against total product against labor. So you're going to put labor and put 0 there. So this is the maximum. You can cut it like that. And then remember that you also have average product here. So you can put it like that. But this line is not supposed to be there. Marginal average product basically just comes there. we're just sorry, let me just do this. Didn't look clean. Okay, so let's say if you go like that, then it goes like that. So one, this part where it is intersecting with total product, average product intersects with total product, that's where it reaches its maximum. That's a point where it cuts the marginal product at its maximum. That's that part. So this is average product of labor. So this is how the graph is going to look like, removing, excluding that. So this is how the graph is going to look like once you plot that graph using those coordinates that we found. Okay, so this is how your graph is going to look like. Probably it might look a bit dirty. Just make sure that if you don't plot it properly, it might look a bit dirty, but if you plot it properly, it look like this. But that's how it is. That is how it is, where you get to illustrate the increasing returns, diminishing returns, and yeah, so diminishing returns. So diminishing returns is all this part, and negative returns, that there, the 3 stages of production. Okay, so that is how you are going to illustrate that first part of the question. Okay, you move on to C. C is saying, in terms of labor, what does the law of diminishing returns state? So the law of diminishing return states that, or the law of diminishing marginal returns states that the more you're adding a variable cost, a variable input, which is mostly labor, to a fixed input, which is capital, marginal revenue, marginal product of labor eventually reaches a point where it starts to decrease. It will start going down. Okay. We are holding what's this, everything should be constant, so we're just going to be adding labor to capital, which is fixed, while you're going to be considering the technology that is being used at that specific time. Okay, so that is how you state that. We move on to D. D says determine where the law of diminishing returns start operating on your graph. So like I had already mentioned, to those that were paying attention, I talked about the 3 stages of production. Let me just go back. Okay, so like we have 3 stages of production. We have increasing returns, diminishing returns, and negative returns. So this part, let me just put it there. So this part states increasing returns. Increasing returns. It means that the more you're adding labor to a fixed input, the output are going to be increasing exponentially, to be increasing. The moment you reach a point of inflation, marginal product of labor starts to decrease. You're going to find that diminishing marginal returns starts to operate. This is the part now. It starts to decrease. It will decrease until it reaches 0. If this reaches 0, total product, it means that total product has reached its maximum. And if you produce more after marginal product has reached 0, it means that this will start producing, it will start decreasing. It will mean that there will be now negative returns. So this is the part now, negative returns is there. Okay, I hope that is clear enough. Sorry for that. Okay, sorry about that. Okay, let's just go back. All right. So that is how you get to state all those things, and that is what happens there. So we move to question 2. So question 2 is saying, suppose you have suppose you are given the inputs, the input bundles along the isoquant Q in the table below. So you are also told that the price of capital is 60 and the price of labor is 5. So what you do here, if you've been given the cost bundle, these bundles that you've been given, the input bundle, and then you've been given this as well, it means that you are somewhere like at this point. You have something like that. So you're going to be choosing bundles like that, and then you have an isoquant there. So it's at that point. So this bundle, if we are saying bundle A is there, it means that A if we use this point, A will produce whatever we're going to produce as equal outputs. What we're saying is that an isoquant is simply a curve that shows possible various combinations of inputs that give the same level of outputs that are produced by the combination of inputs. Okay, so that is what I'm saying. So this level of inputs, this one and that one will give the same thing, that and that will give the same thing, and that will give the same thing. All these combinations will give the same thing, but if all these are on the same indifference, I mean isoquant, it means that they'll give the same level of output. Okay, so how do we find this question? Going direct to the point, how do we find this question? So this question is going to be found like this. Since we've been given the price for capital and the price for labor, we just need to find total costs. Okay, we're just going to try to find total costs. How do we find total cost? Capital is 60 and we have one capital, so we multiply 1 times 6 60, it's 60, right? We're going to have 60 there. We're trying to find total cost, by the way, which is total cost. Total cost is given by total cost is equals to total fixed costs plus total variable costs. So we have variable costs and fixed costs there. So that's what we're trying to do there. Okay, so we have 60 times 1 is 60 plus 5 times 100, it's 500, right? We add that it will give us 560. So we put 560 there as our total cost. So we continue doing that, until we reach this last part, and we answer the question that follows. Okay, once we finish everything that is there to been given. So the first question was saying calculate the cost minimizing bundle. So the cost minimizing bundle is simply the total cost that has the lowest value. So like here you have 560, 60, maybe you're going to find 3 something there, maybe 5. So you get the lowest, the one that will have the lowest, that's the answer. Okay, so like here they're saying that calculate the cost minimizing bundle. So the bundle you can just pick, you say maybe if you found C, you say C. If you found B, you say B, which has this and that, and then the cost was that. So that is how you answer that. As simple as that. Yes, it's simple, right, guys? So probably this is very simple. Okay. B is saying you are informed that the price of capital has now increased to 80 and that labor has remained 5 kwacha. Calculate the new cost. So we are going to do the same thing. Where I just put in 60 there. Why I multiply? You multiplied 1 times 60, yeah? So you do not multiply 5 times 60 now. You multiply 80 times 1. Oh, sorry, I meant 60 times 1. You now replace it with 80 times 1, but 5 remains the same. So you are saying 80 plus 500 is going to give us 580. So you just continue the same thing, but you're replacing. Why you're putting 60, same thing. So probably the question will also ask to find the cost minimizing bundle. Again, you find the lowest. So that is your answer, like we did on the first part. Okay, so we move on to question 3. Question 3 was saying you are given the following production functions. Which ones represent constant returns to scale, increasing returns to scale, and which one is decreasing returns to scale and why? Okay, so what you have to know first is this. For you to state increasing these returns to scale is that we have to follow, we have a rule that we follow, that there's a rule that we follow which says you have to add the sum of this yeah, the upper part, these powers, you just add the power. If the power that you're going to find is greater than 1, it means that it is increasing the tends to scale. If it is equals to 1, it means that it is constant it tends to scale. If it is less than 1, it means that it is what? Decreasing the tends to scale. Before I even go to any other thing, I also want to, these are returns to scale that talks about productions. We also have economies of scale that talks about the average cost, right? The average cost. So they talk about cost. There, if you find the cost output to be greater than 1, it means that this is diminishing marginal returns. If you find it to be less than 1, it means that it is increasing returns to scale. If you find it to be 1, it means that it is constant returns to scale. I just added this part so that at least you understand what you can think of next if you are to find a question that is asking about that. So here we're just going to be adding this 5.5 plus 0. 0.5 plus 0.7. You add the two. If they give you 1, then it is what you've said. Just like that, you state them according to what I'm just from saying there. By the way, some of you would ask to say, what is this? This is simply 1 over 2. So 1 over 2 plus 1 over 2, it is what? It is 1. Okay, so this is constant returns to scale. Okay, let us move on. Question 4 was saying find a firm is producing outputs using labor and capital in such quantities that the marginal product of labor is, we've been given the marginal product of labor. We've been given to say it is what? 15. And then we've been given the marginal product. If you continue reading this, it says, and the marginal product of capital is 8. And then the price of labor is 3. Then the price of capital is 2. So what they're saying, that if a firm is using the an efficiency factor combination of for production, if is the firm using an efficiency factor of combination? So if not, you have to state why. Why and what it should do for it to achieve efficiency. So you use the marginal principle here. The marginal principle states that the marginal product of labor per dollar of that labor must be equals to the marginal product of capital per dollar of that capital. Okay, or any other things. So we say marginal product of capital labor, and equals to the price of labor is equals to marginal product of capital is over the price of capital. So what you're going to do here, you put 15 there. 15 is going to be there. Then we put 3. We're going to put 3 there. We say equals to 8 over 2. We divide there, we're going to have 5 is equals to 4. These two are not equals. Therefore, these two are not equals. The marginal principle states that these two are supposed to be equals for the firm to be in equilibrium, but these two are not equals. It means that a firm should use the input that gives it more output for it to maximize its output. So for it to reach efficiency, it should start adjusting its inputs by using more labor and using less capital. If that is done, marginal product of capital is going to start increasing, and marginal product of labor will start decreasing. And for that reason, these two are eventually going to be equals once it is adjusted. So it should use more labor than capital. Okay, so I'll cut the video here. We'll start in the next video from question 5. Okay, subscribe to the channel and share the video with your friends. Okay, thank you for watching.